Hey, what's up? It's your old pal, Mr. Cook, and we are now working on the group work second page, and in particular, just the word problems here. So the formulas that you guys are going to use on the test are the same as the ones that are up here at the top on your group work. So just get familiar with them. We're going to use them pretty regularly over here. So some of this stuff might be a little bit of a challenge, especially when we get into the geometric sequences and how they apply to the word problems, because there is a bit of a kind of weird thing that happens with the exponents, but I'll try my best to kind of explain that. And if you still have questions after those ones, specifically 10 and 11, just ask your teacher in the morning if you have a chance, or shoot one of us an email and we'll, try and explain it a little bit better. Okay, so we start off with this one. This is an arithmetic relationship. It says the logs are stacked in a pile. Each row of logs has one less log than the row below. The top row has 8 logs. The bottom row has 20 logs. So if we start at the bottom, that's 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And the top row has 8, 1, 2, 3, 4, 5, 6, 7, 8. That's all we know so far. And we also know that each row has one less than the previous one. So it goes down by 1 all the way up to 8, I guess. So if we start at 20 and then go up and down by 1, to get to the next rows, then that's just arithmetic, right? We're just adding by 1. So an arithmetic relationship. So we can write up the explicit rule. AN is equal to A1 plus D times N minus 1. Common difference is that it keeps, well, let's start with the first term. The first term, let's say it's the row of 20. Then if we keep taking 1 away from it to get to the row that has 8, then we're going to be subtracting 1 log away from it. And that's our sequence. Okay. Now, we're tasked with finding out how many total logs there are in this pile. So that means that we are going to have to find a summation for this one, because it's very much like that auditorium problem. The structure is even the same when you think about it. One less seat in the rows, those kind of problems. So, we're going to use the exact same method for solving the summation for an arithmetic sequence. So Sn is equal to n over 2 times a1 plus an. So luckily, we already have a couple of these things. The first term is the first row, 20. So we have 20 logs in the first row. The last row has 8 logs. So we even know the last number that we're going to use, that an. Here's the weird thing. We don't know what the n value is going to be equal to. Luckily, we can solve for that last row, how many rows that we're going to have, by just using the number of logs in the last row, 8, and plugging it in for an, and then simply solving for the n value, because that's the only thing that we need to solve for. All right, so solving for n, I would subtract 20 from both sides, so I get negative 12 is equal to negative 1 times n minus 1. Then I divide both sides by negative 1, and I'd get 12 is equal to n minus 1. Then I'd add 1 to both sides and get my n, which is 13. So 13 goes on top there, and this is the summation of the first 13 terms. So then it's just calculator time. Forget what I get here, like 182 or something like that. 13 over 2, and then 20 plus 8 is 28. Yeah, 182. So it's 182, and don't forget your units. 182 logs that we're adding up there. All right, so that's number 9. Number 10, a city of, that's supposed to be a comma, by the way, 150,000 people, not 150.000 people. Change that for next year. A city of 150,000 people is growing at a rate of 5% per year. If you're in my class, I told you that as soon as you see that's a growth of a percentage, that's dead giveaway that it's a geometric sequence. You don't even need the second sentence that says it's a geometric sequence, because you're pretty much guaranteed that that's what it is. And since it's growing at that rate, that means that we're adding on an additional 5% to the 100% of the people that are already there. So if it's 100% and we're adding on 5 more percent, that's a total of 105%. And that gives us our common ratio for the geometric sequence. But we need to convert it to a decimal. So 105% as a decimal is 1.05. That's our R value. Our initial amount that we started off with is the city's population at first, which is 150,000 people. So to write a formula to describe it, and I'm going to forget about this stuff for right now, okay, because I don't like that. That's stupid, and I'll explain why in a second. The population is going to be equal to the starting amount, 150,000, times our common ratio, 1.05 to the power of, and here's where it kind of gets a little bit tricky, so pay attention. It could be n minus 1, as it usually is for our geometric sequences, but it depends on what we call 1, you know, like, and I better use the same variables that they're asking us to use. Time, there we go. If t equals 1 represents the initial amount, this is fine, because if we plug in 1, we get 1 minus 1, which is 0. Anything to the 0 is 1, and 1 times 150,000 means that when t equals 1, initially, we have 150,000 people. However, if t equals 1 means that 1 is after year 1, since the population is growing, then after 1 full year, the population should have grown by 5%. However, once again, if we plug in 1 over here, 1 minus 1 is 0, anything to the 0 is 1, so after a year, we'd still be stuck with 150,000 people. So this thing actually means a lot. If you say that t equals 1 means that it's the population after 1 year has passed, then that means that you need to do something pretty drastic, and that's get rid of this minus 1 here. Because then, when you plug in 1, the 150,000 will multiply by 1.05, making it larger. If you don't get rid of that minus 1, it's 0. So that means that after 1 year, the population will not have grown. We're just going to use this formula because then it doesn't screw up this stuff over here. So we're going to use the formula to find the population in year 10. So what we do is we just simply plug in 10 to this, and we get our population. So it's 150,000 times 1.05 to the power of 10. And then we just type it into our calculators and see how much that is. Remember, we want to round it to the nearest person. So there we go, 150,000, 1.05 to the power of 10. So we get, oops, not money, geez, 244,334 people. Wonderful. All right, so that solves our problem, and we're on number 11 now. Number 11, a new car worth $45,867 drives off the sales lot and begins depreciating at a value of 12% every single year. Yikes. So that's depreciating pretty quickly. Maybe it's a kind of crappy car, I don't know, but if it's depreciating by that amount, first off, if it's a percentage, I know it's going to be a geometric relationship. And by depreciating, it means that it takes the initial car's amount, all 100% of it, and it reduces it by 12%, meaning that the car after a year is worth exactly 88% of its initial worth. So as a percentage, 88%, we get our common ratio. So we just need to convert it to a decimal. That's 0.88, and that gives us our R value. Our initial amount was 45,867, so we plug that in to the formula for a geometric sequence, and we get the following. AN is equal to our first term, 45,867, times 0.88 raised to the power of n minus 1. Uh-oh, let's check and make sure that this makes sense. So if I plug in 1 for n, let's make sure, all right, so let's see. Let's say that n is equal to the time that I have, you know, like the price of the car after 1 year of ownership. So after it's 1 year old, should it be worth the same amount or should it be worth less? Think about that for a second. It should be worth less than that amount, right? Because if I'm driving it around, you know, people are not going to spend the same amount that I spent on the car, so if they want to buy the car back. So that means that if I plug in 1, it should be less than 45,867. I don't know where I got that other number from. So if I plug in 1, what do I get? 1 minus 1 is 0. Anything to the 0 is 1. 1 times 45,867 is 45,867. So it didn't lose any money. So this is when you need to take off the minus 1 on this word problem. There are some cases where you leave it on. You just kind of need to make sense of it in the word problem, you know, in the context of the problem. So make sure that you pay attention to that. Okay, anyways. Now, this is my formula. Let's use the formula to figure out how much the car is worth after 6 years. So what we're going to do is just plug in 6 for n without any issue. And then let's see what we end up with. Now this is going to be an amount of money, so I can put my little dollar sign on there, 45,867, and then 0.88 to the power of 6. You get $21,300.82. That's our answer. And that's all of the word problems. You know, there's more word problems that you guys can practice, obviously. on your own time. We have a lot of practice, and we've been going over them all week, so, practice those more. Last couple problems are pretty easy. Put the sum in sigma notation, and then find the sums and show all your work. So, start with your little sigmas for each of these. There we go. All right. And then, since it doesn't tell us where to start, let's just put n equals 1 on all these. So then we can assume that the first term is where we're starting with, or finding our summation. And then to figure out where it ends, just count up how many that you have. So n equals 1, 2, 3, 4, 5, 6, 7, 8. So to 8 here. N equals 1, 2, 3, 4, 5, 6, 7, 8. So 8 here as well. And then 1, 2, 3, 4, oh, dot, dot, dot. That means that it goes infinitely. So we put a little infinity symbol there. All right. Now we need to figure out the equation for it, the explicit rule. Since this goes from 12 to 10 to 8 to 6 to 4, it keeps going down by 2. So it's arithmetic. So we write out the first term minus the difference, and then times n minus 1. You're done. That's sigma notation right there for this summation. Okay, next, same thing here. 1/3, 5/3, 3. Uh-oh. Well, rule of thumb, if you see a bunch of fractions and then non-fractions, turn them into fractions. So this is the same as saying 3 over 1. This is the same as saying 7 over 1. Next, they all have denominators of 3. Let's not break that pattern. So this is the same fraction as 9 over 3. And then 7 over 1 is the same as, if I multiply the top and the bottom by 3, 21 over 3. Then look at the bottoms. They're all the same, 3. And then the tops, they keep adding 4. So that means that each fraction, to get from fraction to fraction, we add 4/3. So it's another arithmetic sequence. They can be fractions, that's fine. So the first term is 1/3 plus 4/3 times n minus 1. There we go. There it is in sigma notation. And then the last one, 8 to negative 4 to 2 to negative 1. These just keep dividing by 2, so 1/2, and then they keep changing signs, so probably negative 1/2. And then it starts at 8, and then to the 1/2, to the n minus 1 power, because it's geometric. There we go. So there's our sigma notation for that one. All right, now let's find the sums. So since this is arithmetic, let's just use the formula. Sn is equal to n, so the number of terms, 8 over 2, times the first term, 12, plus the last term, negative 2. So that's 4 times 10, so 40. That's pretty easy. Right, so probably faster than even typing it in the calculator. For this one, it's arithmetic, so I can use the same rule. So the sum is equal to n over 2, so 8 over 2, times the first term, 1/3, plus the last term, 29/3. 1 plus 29 is 30. 30 over 3 is 10. 4 times 10 is 40. 40 again. That's definitely faster than typing all those fractions into your calculator or this mess in your calculator. Now for the last one, it's an infinite geometric series, and our common ratio, r, if I take the absolute value of it, is definitely between 1 and 0, so that means that it converges. And that also means that we can use our nice little formula for the infinite geometric series. The sum is equal to a1 over 1 minus r. Okay, so let's translate that into this whole thing. So if we plug in 1, we end up with 8, so our first term is 8. We actually see it on the sequence also, so 8 is our first term in the sequence. And then it's 1 minus our common ratio, which is negative 1/2. So we get 8 over 1 plus 1/2 is 3/2. And then if I divide by a fraction, it's the same as multiplying by the reciprocal, so it's 8 times 2/3, which is 16/3. So there's our last sum. So that completes the group work. This is a little bit, much. I think that, we probably have something close to this, but not, I think, as difficult. Like this part took up a lot of time, but, it should be a pretty straightforward test. Make sure that you come in and get some help if you need it in the morning before the test. And, yeah, that's about it. Happy studying, I guess. And, oh, yeah, I was supposed to give a shout-out to Miss Schmisser's third-hour class. So, hello. That's all. All right, thank you. Bye.